Pause the video now, guys, and try question number 15 on the AQA A-Level Maths Paper 1, okay, the 2-hour paper, okay, for solving a first-order differential equation involving the separation of variables, okay? So pause the video, try the question, and then come back and press play and check your answer or answers along with me, okay? Question 15, guys, says the following. The height x meters of a column of water in a fountain display satisfy the differential equation dx by dt is equal to 8 sine 2t, where t is the time in seconds after the display begins. Part A. Solve the differential equation given that initially the column of water has 0 height, so this would be important. Okay. Express your answer in the form x equals f of t. So our initial condition will be that, yeah, x is equal to, so x of 0 is equal to 0, i.e. t equals 0 when x equals 0. Okay, this is just my notation of doing it. Okay, x of t equals that. Okay, 0 equals f of 0. Okay, so step 1, cross multiply. Okay, so get all the x's on one side and all the t's on one side. So I'm going to have 3 root x dx is equal to 8 sine 2t dt. I'm now going to integrate both sides. Guys, we're taking my time with the integration. Okay. But before that, I'm going to write the left-hand side in index form to make it easier to integrate. Okay. So I'm going to have 3x to the power of a half. So now integrate both sides. What am I going to have? So the integral of this and the integral of this. Okay, I'm going to add 1 to the power and then divide by the new power. So I'm going to have 3x to the 3 halves. Okay. Now remember, I'm dividing by that new power. Dividing by 3 halves is the same as multiplying by the reciprocal. So the same as multiplying this by 2/3. Okay. The 3's are going to cancel when you do that actually. Okay. So I'm left with 2x to the 3 halves. Okay. So sorry if I actually jumping into a step there, but you have 3 times 2/3, which is 6/3, which is equal to 2. Okay, check that yourself here if you're unsure. I'm then integrating this. Sine goes to minus cos, and here I'm going to be careful. I'm going to differentiate what's inside here and then divide by it. Okay, so I'm going to have minus 4 cos 2t. Okay, you differentiate the 2, okay, and then divide by it. Okay, sorry, yeah, that is obviously for integration. Obviously, if you're differentiating that, then it would come out as a multiplier, okay? But if you're integrating it, you differentiate this and then divide it by 2, okay? And then put the plus c. Now this is going to start being obviously a bit more nasty when I actually rearrange it. So I'm going to have x to the 3 halves is equal to minus 2 cos 2t. Plus c over 2. So I'll call it a new constant. So I'll call it, let's say I'll call it k, where k equals c halves, k or c over 2. Okay. In here, it doesn't actually matter because the constant will actually give out the same answer, okay? But if you're being that picky, then obviously when you check your answer, obviously c will actually be like double of whatever k is, okay? Right. Rather than raise both sides to the power of 2/3 here, I'll leave it in this form for now. So when I make the substitution, it makes it a bit easier to rearrange for k. Okay, so we're going to have 0 to the power of 3 halves, which should be 0, equals minus 2 times cos 2 times 0, That'll be cos 0. Cos 0 is equal to 1. We're going to have minus 2 times 1 minus 2, and then plus the k. So if I rearrange this equation, we get that k is equal to 2. So our constant is equal to 2. Okay. So I can replace this with 2. Okay, remember, so c over 2 is equal to k. Okay. If k obviously equals 2, then obviously c would obviously equal 4. Okay, same idea. Okay. But if you really obviously want to obviously make it look a bit neater, then yeah, you would have x equals 2 minus 2 cos 2t. All to the power of 2/3. Okay, because to undo a power of 3/2, I have to raise both sides to the power of 2/3, because the index laws will cancel out the power on my left hand side. So that's how, and that's the reason why I get that. Okay, and that, guys, is my final answer, okay, for solving quite a tricky and quite a nasty first order differential equation. Okay, so there was a lot obviously in there. So revise your integration. Okay, revise the rules here for sine, cos, and tan. Remember, sine integrates to minus cos. Okay, and then cos integrates to positive sine. Okay, so follow that cycle. Okay, well, that's my answer for that question. Okay, thanks for watching. Take care. All the best. Okay, good luck with the revision. Okay, please share this video and share the TikTok and YouTube page with anyone that might find it beneficial for the upcoming paper 1 exam, which is a week on Tuesday. Okay, thanks for watching. Take care. All the best. Bye for now.